Assalamu alaikum. So this is a tutorial for computer engineering practicum where I'm going to solve a design problem. So I have this water irrigation system and you're asked to design this system where a user switches it on from a control panel and the system should work for 5 seconds only. For the water sprinkler, you should operate a servo motor to rotate continuously. So this is the second output for the system, and assume that the system is wired, so everything is connected to each other. The first task is that we have to sketch the schematic of the circuit to do this, and we have to show the calculations for all the different circuits. And then you have to implement the circuit on a breadboard and test it. I'm going to use the parts list to find out what is the resistance. So I need 4.54 mega ohm, and I can use for that 2.2 mega ohm plus 2.2 mega ohm, which is 4.4 mega ohm. And so I need around, since I need 4.5, I have around 100k, maybe 150k missing kilo ohm. So the total resistors I need to make the 4.54 mega ohm are 4 resistors, 2 which are 2.2 mega and 100K, and the other is 47K. I can also calculate the percentage error by seeing how much the value is deviated from the target value, which is 4.54. So I'll just subtract the two resistance values and divide it over the original resistance value, which is 4.55 mega ohm, times 100 to find the percentage error, which will be equal to around 1.8%, which is less than 5% error if this was the requirement, and it's reasonable amount of error. Now keep in mind, when you have mega ohm resistor, you cannot just round, because a 0.5 mega ohm is actually 500K ohms. So you actually have to make this resistance, otherwise, or calculate it and add it to the value, otherwise you'll have really huge error. Now I can go ahead and draw the schematic. So you can just check the pinout or diagram of the 555 timer from the data sheet. And for R1, I'm going to put 4 resistors in series. And the upper one will be connected to 5 volts. And then from the other side, it will be connected to both pin 6 and 7. Or you can connect to pin 7, and 7 will be connected to 6. And then the 1 microfarad capacitor is going from pin 6 to ground. And we also have a switch at the trigger pin, which is pin 2. And the switch is connecting the trigger to ground. And there will be a pull-up resistor of 1 kilo ohm to 5 volts. So when I press the switch, it will make the trigger go to ground, or like to 0 volts. And that's how the monostable mode actually works. And finally, I'll connect my LED light with the resistor in series for protection. And then I will connect this output of the timer, which is pin 3, to the VCC of the second 555 timer. So it's like I'm saying, only when this switch is pressed, we will supply voltage for 5 seconds to this Astable timer so that the servo motor works. And I will use the same values from the lab to make the servo motor rotate at a certain direction. Here it's not mentioning whether it's clockwise or anti-clockwise, but if it was mentioned at a certain direction, then you have to follow the same on time for which is basically the pulse width of this signal. And in the Astable mode, the pin 6 and 2 are connected together. And you have 2 resistors. So one resistor is connected between the 5 volt and pin 7, and the other one is between pin 7 and 2, which is R2. And here it's 14.7K, and we need to put 2 resistors in series for this based on our parts list. And then we have the capacitor connected to pin 2, which was calculated to be, or maybe assumed to be, 0.1 microfarads. And the rest of the connection is the same. Now the output of the second timer should be connected to the signal pin on the servo motor. So the servo motor has 3 pins. You can see this implementation on this one for the here. Signal. So I have the switch, and one I have the 2 timers, LED light, and the servo motor connected. The servo motor I'm using has black as ground, black wire, red as VCC, and the white wire is the signal. There's also another type of servo motor. You have to check which one, the color code of the wires, and then connect accordingly.